just a few things to mention. I didn't make it up to director, just leading the team on digital twin development, and we're coming outside of the mechanics and control department, so all our implementation are very heavy on simulation, prediction, and optimization. So what was our role in the change to twin deployment vouchers? So as said before, we assessed 4 SME companies in the assessment phase, and 2 of them then also got funded for deployment phase. So they are very different in their digital, in the level of digitalization inside the company. So Salvagnini, the use case, they have a very highly digitalized thread for their machines, so they have all the sensors in place, they acquire the data, they do analytics, and they also do simulation. Whereas on the other side with RO-RA, which is a company in the aviation sector, they produce structural rods for airplanes. So their production process, it's a rotary swagging process, is not highly digitalized. So in this deployment voucher, we support them also with sensor integration, connectivity using the DTTech's Nerve Edge device, and then building up an aggregated database that they can understand the process better and make more informed decision about how to commission the system in order to get the first time right approach. Since this deployment is currently on the way in the second wave of deployment vouchers, I will talk more about an already finished deployment project with Salvagnini Maschinenbau. So this is a company partner from Austria who has a competence center for pending technologies just near LCM, and they're responsible for the development and the production and also the after-sales process for Salvagnini panel benders. And I would have a video on the right side. Let's see if it works, where you could see one of these lines working. Let's see. It did work in the not full screen mode, but yeah, we just skip it. Okay, so you would just see end-to-end going from sheet metal to a finished product. And what I want to highlight is that the precision is very important, so the machine quality and the components of the machine have to have a really high health status in order to be able to produce high quality products. So when we did the assessment, we came up that their most important KPIs was that they want to further increase their customer satisfaction, that they want to decrease the total cost of ownerships of these machines at their customer, and they also want to get feedback from the production of their customers in order to create even better machines. So in the assessment project, we decided that the asset was clear. We will improve their machine, and we will do this by rolling out a digital twin for predictive maintenance, who does a mechanistic remaining useful life prediction of the major components. So our role in this deployment voucher was that we consulted Salvagnini Maschinenbau, and they are world-class designers of machines, and they have extremely high knowledge in bending technologies, but what they're missing is statistics, machine learning, and also simulation capabilities. And these were the points we brought into this project. So first, starting off with choosing what components they wanted to monitor. It was very tempting, since they have a huge database. They acquired 5 years data of 512 machines in the field. So it was very tempting to just go for all components, and because they had a lot of data, but we then figured out that we should maybe concentrate on the most important ones and do this properly. And this was the better decision, because we barely ended up doing the 3 components. So maybe 1 component would have also been enough, but we focused on bearings, hydraulic actuators, and the rotator clamp, which is responsible for manipulating the metal sheet. So in the process, we analyzed their historical data, we analyzed failure cases, and we built up a digital twin for predictive maintenance for RL, remaining useful lifetime calculation. So as mentioned, Salvagnini has great knowledge on bending technologies. They also established the complete digital thread, so they have sensors integrated, streaming all the production data from the field to a database. They use Power BI in order to analyze this data by hand. And the goal from the project was to come up with a module who does the work of the service engineer automatically. So analyzing all the data and using a digital twin to compute missing data and to predict the remaining useful lifetime of these 3 components. And what we brought in, we also brought in the University of Applied Science Upper Austria as a scientific partner in order to use simulation-based surrogates of the machine. So these are finite element models which accurately display the machine, also the production process, and create a surrogate model which then in the operational phase can be used to acquire data which cannot be measured, for example, contact pressure in the bearings, and then use these values in order to predict the lifetime of the individual components. So we ended the deployment voucher after the foreseen 11 months, and at the end we had a solution up and running for all the different machines in the field, now being able to predict a remaining useful lifetime, which in the future should have the following impact, that it will reduce the service expenses at Salvagnini, so that they can schedule maintenance and send out their maintenance fleet in a better and optimized way. It will increase the uptime at their end users, at their customers, by not having machines breaking down because of component failure. And they will also use all this data generated to make better decisions for coming up with improved machine designs. So what were the main lessons learned? So as said, it's very important to identify the gaps, so what the SME really is expert on and where he misses knowledge, and then fill this gap with competent partners. And especially for these very short projects, it's of utmost important to bring in partners that speak the same language, that really know what's important for this production process and how the company or the process works. And it's even, at least for us, we've seen that quite some time, that speaking the same language also really means speaking the same language, because we saw that operators and service engineers have a lot of knowledge which has to be used, and sometimes they do not really speak English, and then a lot of things can be lost in the translation. So also speaking the same language, especially with field operators, was also a big benefit for us in different projects. The second point is, do not rely on historical data only. We had a huge database here. It looked like we have everything what we need, but of course we developed this model to work best on newly developed machines, and the failure cases we investigated were all machines which were older and didn't have the sensors we want to use for predictions. So we had to reversely engineer and match old machines with new machines to come up with these models. So, and also from our experience, we were not positively surprised one single time with the data we got. It was always not enough, missing data, even if it's a huge amount and the quality was not good or the data wasn't annotated. So we always rely on the plan B to do simulation in order to find out relationships and do not rely on the data only. And the last point is, start with a small minimal viable product, get something up and running and see how it works, and then iterate on it, improve it, and also show quick wins that the company partner or their management is also on the same line and goes on with this digital twin project. So this was the experience from my side, and I think discussion will be on the panel, right?